Okay, so this number, or this math problem, is in hexadecimal. Hexadecimal means hex 6, decimal 10, so 6 plus 10, 16. So we're in base 16, which means we need 15 different digits to use. So rather than writing 11, 12, things that are double digits in a single spot, we use A to represent 10, B to represent 11, C for 12, D for 13, E for 14, and F for 15. And then at 16 is where we would carry. So we only need from 0 to some representation for 15 in order to do this problem. So that's what we're going to go with. And this is a little weird at first, but if you think about, you know, when you play cards, jacks, kings, and queens, you know those in your head from playing it for long enough, that king's 13, queen's 12, jack's 11, so forth. So this is the same kind of concept. All right, so we're going to begin again in the, we got a helper here. There he is. Okay. All right. We're going to begin in the ones place. So we have E plus 5. Now remember that E represents 14. So 14 and 5 makes 19. 19 is one group of 16 and 3 leftovers. Okay. And then we look at 1 plus A meaning 10. So that's 11, which would be represented by B. All right, the cat's had enough. He's got 2 place values and he's gone. All right, and then the third place value here, now we've got 3 plus B. B is 11, remember. So 3 plus B would be 1, 2, 3. We'd be at 14, would be at an E. So our final answer would be EB3. If we want to, we could put the little 16 down in the corner here to remind ourselves that we're working in hexadecimal. Okay, so now our job is to go along and look at these place values. We've got 1s, we've got 16s, and 16 groups of 16, you may not know this off the top of your head, is 256. And that would be a good place for a calculator if you need one. Okay, so now what we've got to do is we've got to translate this back into base 10. And I am actually going to employ my calculator on the side here. I won't show you that in the video, but I'm just going to fire it up and I'll be using it off to the side here. Okay, so what we need to do in order to translate this bottom number, we've got E, which represents 14 groups of 256, all right? Then we've got B, which represents 11 groups of 16, okay? And then we've got 3 1s, all right? So off on the side here, I'm going to figure out what is 14 times 256, and that is 3,584. And then 11 groups of 16 would be 176 and 3 more. So we'll just add that all up together. And I probably could do this in my head, but it's tired and I want to go pet the kitty. All right, so 3,763 is what EB3 represents. So let's write that over here. Remember what we talked about in class, as our bases get smaller, our numbers get longer. So look, this number was only 3 place values in hexadecimal. It gets longer in base 10, which is the opposite of what happened with our other 2 examples, where we had smaller bases going to bigger with base 10. All right, so how about B05? So B represents 11 groups of 256, and 0, obviously, no groups of 16, and then 5 more. So we'll take 11 times 256 off on the side here, and then we will add 5 to that. So that was 2816 plus 5, which is 2821. So that is that middle number in base 10. Oops, sorry. And then the last number, we've got 3 groups of 256 plus A, which is 10 groups of 16, plus E, which is 14 1s. All right, so 3 times 256 gives us 768 plus 160 plus 14. We'll put that all together, and we have 942 base 10. So now our check would be to take 942 plus 2,821 and double check that that gives us 3,763. If you look, 2 plus 1 is 3, 4 plus 2 is 6, 9 plus 8 is 17, carry the 1, and yes, we get what we want to get. So this problem translated back over to this checks out and makes sense.